Factoring trinomials. At the end of this lesson, you should be able to answer, how do I factor a trinomial? So please remember that a trinomial is simply a polynomial with three terms. We're going to be looking mainly at trinomials that fit the pattern that you see below, ax squared plus bx plus c, and I really should say plus or minus because these signs could be a positive or a negative. And a, b, and c are just taking the place of numbers here. So what we're going to be doing is you're going to be given a trinomial and you have to figure out what two binomials multiply to give you that trinomial. And to help you think this through, consider something like x plus 2 times x minus 5. To simplify that, you FOIL or distribute. First would be x squared, outer is minus 5x, inner is plus 2x, and last is minus 10. So when they're in this format, typically your two middle terms combine and you get x squared minus 3x minus 10. So you're going to be given this line and you have to come up with the two binomials that multiply together. So the easiest way to do this is focus in on this last term, this negative 10, and think about factors of negative 10. Now the fact that it's negative should immediately tell you that one of your factors has a plus sign and the other has a minus, meaning it came from a positive 2 times a negative 5. So when I am given a polynomial, I immediately look at this plus c or minus c. If it's a positive, the only way that would be obtained, for instance, if it had been a positive 10 at the end, that would come from either positive 2 times positive 5 or a negative 2 times negative 5. So when it's a plus right here, in my constant term or my last term, this tells me that the factors have the same sign. If it's a minus, the factors have different signs, and I'll kind of talk you through this as we go through different examples. So let's start by looking at a trinomial that's fairly simple. X squared plus 6x plus 5. So I start by setting up two binomials, and I think about how I would achieve this trinomial. The only way to get x squared would have been x times x. Since all my signs are positive, I know that everything has to be positive in the binomials. But again, I start by here. Since it's positive, it tells me the signs are the same. So I put two pluses. Now, technically it could be a negative times a negative, so I look at the middle sign next. Since that's a positive, this one here tells me they're the same, and then this one tells me what that sign is, both positive. So now I need factors of positive 5. That would be 1 times 5. That's it. So I try that and see if it works. If it doesn't, this would be prime. And how do I see if it works? Well, that means I check it by foiling together. First, x squared, outer would be plus 5x, inner is plus 1x, last is plus 5. My middle terms combine to 6x, so it works. This is the factored answer. In number 2, again, two binomials. Well, the only way to get x squared is x times x, and I need to look at this sign. Since it's positive, it tells me the signs are the same. So then I look here, that tells me that they're both positive. All right, now factors of positive 24 would be 1 and 24, 2 and 12, 3 and 8, 4 and 6, and I need a pair that would add to 11. Well, that's going to be 3 times 8. Now again, I check it by foiling, or the distributive properties. That would be x squared, outer is plus 8x, inner is 3x, and last is plus 24. My middle terms add to 11x, so this is the factored form. Occasionally students will ask, does it matter if I put x plus 8 before the quantity of x plus 3? And the answer to that would be no, because of the commutative property. You can change the order in which you multiply and still get the same answer. Okay. In number 3, switch the variables on you because I don't want you to get too set and always using x. All right, I have an a squared, so that's going to be a times a. Now this time, this is plus, tells me the signs are the same, and I look here and it's a minus, so I know it's going to have to be a negative times a negative. So I need factors of positive 18, and I know they both have to be negative, so that's like negative 1 times negative 18, negative 2 times negative 9, negative 3 times negative 6, and right there, that's what adds to negative 9. So it'd be a minus 3 and a minus 6. Again, check it by doing foiling or doing the distributive property. A squared minus 6a minus 3a plus 18. My middle term checks out, so I have it factored right here. Number 4, again I switched out the variables, b times b. And I need to look at my signs. So positive means my signs are the same. This tells me they're both negative. So I'm going to have negative factors like negative 1 times negative 56. Negative 2 times, that would be negative 28. 4, negative 4 times negative 14. Negative 7 times negative 8. And I needed to add to negative 15. So there we go. So it's going to be b minus 7 and b minus 8. So do a first, outer, inner, last to check it, and you can do that on your own. For sake of time, I'm going to keep moving here. All right, number 5. Now here's the first time that I have a negative right here. That tells me that my signs are different. The only way I'm going to get negative 36 is to have one be a plus and one be a minus. So I need them to add to negative 9. So it could be 1 and 36, but what I really am thinking is really it could be negative 1 and 36 or positive 1 and negative 36. So what I've always done, just because it's a little bit faster, is I think about, well, what would the difference be? 1 and 36, and then I only have to, rather than doing 2 extensive lists, just do like 2 and 18, 3 and 12, 4 and 9, 6 and 6. And then if I just find the difference, meaning subtract, so the difference here would be, in this one would be 35, here it would be 16, here it would be 9, so there it is. It's going to have to be a combination of 3 and 12. So it could be positive 3 and negative 12, or maybe I have to switch them, positive 12 and negative 3. But I think I have it because it needs to be negative 9, so positive 3 and negative 12 does add to negative 9. Now definitely with this one we should check it because we did a few shortcuts there with our signs. Factor or FOIL to check it. So x squared, outer would be minus 12x, inner is plus 3x, last is minus 36, so I do have it correct. Okay, number 6. Again, I have a negative for my last term. So that tells me that my signs are different, meaning one's a positive and the other's a negative. Factors of x squared would be x and x. So I need factors of negative 12. And they're going to need to add to positive 4. So again, if I just list all my positive ones, 1 and 12, 2 and 6, 3 and 4, and I think about, well, what's the difference between those since one needs to be positive and the other needs to be negative? 2 and 6 has a difference of 4 when I take 6 minus 2. Now, if I put the 2 here and the 6 here, I think that's going to be wrong because that would be positive 2 plus negative 6. That's going to be negative 4. So I have to flip-flop those. I purposely did that wrong so you would think about it. So positive 6 and negative 4. Oops, I'm sorry. Just put the wrong sign there. 2. 6 times 2 would be 12. Positive 6, negative 2. Now let's do a check, especially since I jumbled my words there. X squared, outer would be minus 2x, inner is plus 6x, and last is minus 12. So it looks like all my signs work out. Okay, in this one here, we are going to combine it with a factoring method that you've previously learned. Notice how this is different than any of the ones we've done so far in this video. The coefficient right here is not 1. Here the coefficient is not 1. Every example on the paper thus far has had a coefficient of 1. In Algebra 2, you'll look at more advanced factoring methods to deal with that. However, when that happens here in Algebra 1, the first thing you want to do is try to factor out the greatest common factor. So when I look at 5, 15, and 50, I know that the GCF is 5. So I begin by doing the distributive property in reverse. I factor out 5, which results in a squared plus 3a minus 10. Now I have a trinomial. I do not drop that 5, but I know that there's a possibility that that will factor further. So I think about, I list my A and my A. The fact that this is a negative 10 tells me that I have a plus and a minus. Now my factors of 10 would be 10 and 1 and 5 and 2. I'm going to try 5 and 2. So I'm going to put positive 5 here and minus 2 here, because positive 5 times negative 2 is negative 10, and that would add to positive 3a. So there, I've got it. And you're going to discover that the more you do of these, the quicker you get. There are other methods I can show you. One of them is the Tic Tac Toe Method. So if you're finding this really difficult, you could go to YouTube and try Tic Tac Toe Method for factoring. If you just type this in, you'll probably find an assortment of other videos that will show you alternate methods. But what I'm showing you is the fastest way for mental math. If you are very weak in your mental math skills, like your multiplication facts, then this way might be challenging for you. But I would encourage you to practice. The more you do, like I said, the quicker you'll get. All right, in number 8, I notice I have a coefficient greater than 1, so I'm going to start by factoring out my GCF. This time it's not only 2, but it's 2y. So I divide each of these by 2y. That results in y squared plus 10y minus 24. So again, I don't drop my GCF, but I split. Now I'm going to factor the trinomial into 2 binomials. So factors of y squared would be y times y. Again, a negative 24 tells me that one's going to have to be positive and the other has to be negative. So I need factors of 24. And I'm going to think about, well, whose difference would be positive 10. So I'm thinking 12 and 2. Positive 12 and negative 2. And there we go. You can take the time to FOIL it back together to make sure that it works. The final one that we're going to do here is an example of area. You're given a rectangle and you're asked to determine the length and width. Well, hopefully you remember that area of a rectangle is obtained by doing length times width. So if you are starting with the area, if that's what's known, you are being asked really to discover, well, what two things multiplied together produce that? And that's your clue that tells you, oh, I've got a factor here. So my factors are going to be factors of x squared or x and x. The fact that I have a positive 18 tells me that my signs are the same. So I look here, and that tells me they're both negative. So factors of 18 that are going to add to 11. 1 and 18, 2 and 9, I think it's 2 and 9, I don't even have to keep going. There we go. You can FOIL to make sure it works. I'm going to say the length is x minus 2 and the width is x minus 9, but really you could flip-flop the two, it doesn't matter. Okay, so that is one method for factoring trinomials. Again, if you feel you need additional help, you can certainly go to YouTube, and there are many different tricks out there for factoring.